Picture this, a team of robots, sleek and futuristic, gliding across the surface of a distant planet, their sensors scanning the alien terrain as they uncover secrets buried for billions of years. These aren't just machines, they're pioneers, pushing the boundaries of what's possible in the vast, uncharted expanse of space. Welcome to the world of space exploration robotics, where science fiction is becoming science fact and the future is unfolding right before our eyes. Today, we're diving into 25 revolutionary developments in space exploration robotics that are reshaping how we explore the cosmos. From autonomous rovers mapping Martian landscapes to robotic arms building space stations, these advancements aren't just cool, they're transforming the way we think about life beyond Earth. So, buckle up and get ready to explore how robots are leading the charge into the final frontier, one groundbreaking innovation at a time. Trust me, by the end of this video, you'll see space exploration in a whole new light. Let's get started. Now, let's zoom in on one of the most iconic advancements in space exploration robotics, autonomous rover systems. These robotic explorers like NASA, Perseverance and Curiosity are more than just high-tech vehicles, they're our eyes and hands on distant worlds. Equipped with cutting-edge artificial intelligence, these rovers can navigate treacherous terrains, avoid obstacles, and make real-time decisions without human intervention. Imagine a robot driving itself across the rocky, uneven surface of Mars, analyzing soil samples, and even snapping breathtaking photos of alien landscapes. It's not just about mobility. These rovers are packed with scientific instruments designed to uncover the secrets of other planets. From detecting signs of ancient water to analyzing the chemical composition of rocks, they're rewriting our understanding of planetary science. What's truly revolutionary is how these autonomous systems have transformed exploration. Instead of waiting hours for commands from Earth, they can think on their own, adapting to challenges and maximizing their productivity. This leap in technology has opened up new possibilities, allowing us to explore farther and deeper than ever before. And as we look to the future, these rovers are paving the way for even more ambitious missions, proving that robots are not just tools, they're indispensable partners in our quest to unravel the mysteries of the cosmos. Moving from the rugged terrains of Mars to the vast expanse of space, let's turn our attention to another groundbreaking innovation, robotic arms. These mechanical marvels, like the iconic Canadarm on the International Space Station, are the unsung heroes of space exploration. Picture this, a robotic arm stretching over 50 feet long, delicately maneuvering massive modules into place, repairing satellites, or even assisting astronauts during critical spacewalks. It's like having a super-precise, ultra-strong hand in the vacuum of space, capable of tasks that would be impossible or incredibly risky for humans to perform alone. The Canadarm, for instance, has been instrumental in assembling the International Space Station itself, piece by piece, like a cosmic Lego set, but its role doesn't stop there. These robotic arms are also vital for maintenance, grabbing onto satellites or spacecraft to dock them securely, or even performing repairs on aging equipment. Imagine a robot arm carefully plucking a damaged solar panel and replacing it with a new one, all while orbiting Earth at thousands of miles per hour. It's a level of precision and reliability that's nothing short of extraordinary. And let's not forget their role in supporting astronauts. During spacewalks, robotic arms act as a safety net, providing a stable platform for astronauts to work from. They can also transport tools and equipment, making these high-stakes missions more efficient and less physically demanding. What's truly remarkable is how these robotic arms have become an extension of human capability, allowing us to build, repair, and explore in ways that were once unimaginable. As we look to the future, robotic arms are set to play an even bigger role. From constructing lunar bases to assembling massive telescopes in orbit, these tools are proving that sometimes the best way to reach for the stars is with a mechanical hand. And with advancements in artificial intelligence and robotics, who knows what incredible feats they'll achieve next? One thing's for sure, when it comes to space exploration, robotic arms are not just helpful, they're absolutely essential. Now, let's zoom out from the precision of robotic arms and dive into the fascinating world of swarm robotics. Imagine not just one robot, but dozens or even hundreds of small, intelligent machines working together in perfect harmony to map the surface of a distant planet. This is the future of planetary exploration, and it's already taking shape. Swarm robotics takes inspiration from nature, mimicking the way ants, bees, or even schools of fish collaborate to achieve complex tasks. But instead of building hives or finding food, these robotic swarms are designed to explore and map alien worlds with incredible efficiency. Picture this, a fleet of small, lightweight robots, each equipped with sensors and cameras, fanning out across a rocky, uneven terrain. Individually, they might seem limited, but together they form a powerful network. Some robots might focus on capturing high-resolution images, while others analyze soil samples or measure atmospheric conditions. By sharing data in real time, they create a detailed, comprehensive map of the planet's surface, something that would take a single rover weeks or even months to accomplish. And if one robot encounters an obstacle like a steep cliff or a deep crater, the swarm simply adapts, rerouting others to continue the mission without missing a beat. One of the biggest advantages of swarm robotics is its ability to tackle rough or unpredictable terrains. Unlike a single rover which could get stuck or damaged, a swarm can spread out and cover more ground, reducing the risk of mission failure. If one robot breaks down, the others can compensate, ensuring that the mission continues uninterrupted. This resilience makes swarm robotics ideal for exploring harsh environments, like the jagged cliffs of Mars or the icy plains of Europa. But it's not just about mapping. These swarms can also work together to solve problems on the fly. For example, if they detect an area of scientific interest, like a potential water source or unusual rock formation, they can converge to investigate further, pooling their resources and expertise. It's like having a team of scientists on the ground, but without the limitations of human presence. As we look to the future, swarm robotics could revolutionize how we explore not just planets, but moons, asteroids, and even the depths of space. By combining the power of collaboration with cutting-edge artificial intelligence, these tiny robots are proving that sometimes the best way to explore the unknown is by working together. And who knows, one day, a swarm of robots might be the first to uncover the secrets of a distant world, paving the way for human explorers to follow. Now, let's shift our focus from the collaborative power of swarm robotics to the incredible capabilities of artificial intelligence in space probes. Think about this. While swarm robots work together to explore planets, AI-powered space probes are venturing even further into the vast, uncharted reaches of our solar system and beyond. These probes, like the legendary Voyager and New Horizons missions, are equipped with advanced artificial intelligence that allows them to make real-time decisions, adapt to unexpected challenges, and continue their missions even when they're millions of miles away from Earth. Take Voyager, for example. Launched in the late 1970s, this iconic probe has traveled farther than any human-made object in history. But what's truly remarkable is how its onboard systems have evolved. While it wasn't originally designed with the sophisticated artificial intelligence we have today, its ability to process data and make adjustments on its own laid the groundwork for future missions. Fast forward to New Horizons, which flew by Pluto in 2015. This probe used advanced AI to analyze its surroundings, prioritize scientific targets, and even troubleshoot issues without waiting for instructions from Earth. Imagine being so far away that a signal from Earth takes hours to reach you. AI ensures these probes can keep exploring, even when they're out of direct contact. One of the most exciting aspects of AI-powered probes is their ability to adapt to the unexpected. Space is full of surprises, from sudden solar flares to unexpected asteroid fields. Without AI, a probe might miss a critical scientific opportunity or even risk damage. But with artificial intelligence, these machines can assess risks, adjust their trajectories, and make split-second decisions to maximize their mission's success. For instance, if a probe detects an unusual energy signature or a potential collision hazard, its AI can analyze the situation and take action, whether that's rerouting its path or focusing its instruments on a new target. This adaptability isn't just about survival, it's about discovery. AI allows probes to prioritize the most scientifically valuable data, ensuring that every byte of information sent back to Earth is packed with insights. And as AI technology continues to improve, future probes will be even more autonomous, capable of conducting complex experiments and making groundbreaking discoveries without constant human oversight. As we look ahead, AI-powered space probes will play a crucial role in exploring the outer reaches of our solar system and beyond. They'll help us uncover the mysteries of distant worlds, study the origins of our universe, and perhaps even search for signs of extraterrestrial life. By combining the power of artificial intelligence with the boundless curiosity of humanity, these probes are pushing the boundaries of what's possible in space exploration. And who knows, the next big discovery might come from a probe that made the right decision all on its own, millions of miles from home. Now, let's turn our attention from the far reaches of space to something a little closer to home, our moon. Robotic lunar landers are playing a pivotal role in paving the way for humanity's return to the lunar surface. These advanced machines are not just stepping stones, they're the foundation of future human missions, and their capabilities are nothing short of extraordinary. Take the Artemis program, for example. This ambitious initiative by NASA aims to land the first woman and the next man on the moon by the mid-2020s. But before humans set foot on the lunar surface again, robotic landers are doing the heavy lifting. These landers are equipped with cutting-edge technology designed to scout, analyze, and prepare the moon for human exploration. They're mapping the terrain, testing landing sites, and even searching for resources like water ice, which could be crucial for sustaining long-term missions. One of the standout features of these robotic landers is their precision. Unlike the Apollo missions of the 1960s and 70s, which relied on human pilots to navigate the final descent, modern lunar landers use advanced guidance systems and artificial intelligence to land with pinpoint accuracy. This is critical because the moon's surface is far from uniform. It's riddled with craters, boulders, and uneven terrain. A robotic lander can analyze the landing zone in real time, adjust its trajectory, and touch down safely even in challenging conditions. But these landers aren't just about getting there, they're also about staying there. Many are designed to conduct experiments and gather data that will help scientists understand the moon's environment better. For instance, some landers are equipped with drills to collect subsurface samples, while others carry instruments to measure radiation levels or study the moon's thin atmosphere. This information is invaluable for designing habitats, spacesuits, and other equipment that will keep astronauts safe during their missions. Perhaps one of the most exciting aspects of robotic lunar landers is their role in resource utilization. The moon isn't just a destination, it's a potential launchpad for deeper space exploration. By extracting water ice and other materials, these landers could help produce fuel, oxygen, and even building materials right on the lunar surface. This concept, known as in situ resource utilization, could revolutionize space travel by reducing the need to transport everything from Earth. As we look to the future, robotic lunar landers will continue to be at the forefront of lunar exploration. They're not only preparing the way for human missions but also laying the groundwork for a sustainable presence on the moon. From mapping the terrain to testing new technologies, these machines are proving that the moon is more than just a stepping stone, it's a gateway to the stars. And with each successful mission, we're one step closer to making that vision a reality. Now, let's shift our gaze from the moon to the vast expanse of space, where another groundbreaking development is taking shape: space mining robots. These futuristic machines are not just about exploring distant worlds. They're about unlocking the untapped resources that could fuel humanity's journey deeper into the cosmos. Imagine a future where robots mine asteroids and moons for water, rare metals, and other valuable materials, turning these celestial bodies into cosmic gas stations and construction sites. The concept of space mining might sound like science fiction, but it's rapidly becoming a reality. Asteroids, for instance, are treasure troves of resources. Some are rich in precious metals like platinum and gold, while others contain water ice, which can be converted into hydrogen and oxygen, essential components for rocket fuel. By harvesting these materials in space, we could drastically reduce the cost and complexity of missions, eliminating the need to launch everything from Earth. Robotic miners are at the heart of this vision. These machines are designed to operate in the harsh, zero-gravity environments of space, using advanced tools to extract and process materials. For example, some robots are equipped with drills and robotic arms to break apart asteroid surfaces, while others use thermal or chemical processes to extract metals from rock. These operations are entirely autonomous, relying on artificial intelligence to navigate, analyze, and execute tasks with precision. One of the most exciting aspects of space mining is its potential to support long-term space exploration. Water harvested from asteroids or the moon could sustain astronauts on extended missions, providing drinking water and oxygen. Even more importantly, it could be split into hydrogen and oxygen to create rocket fuel, enabling spacecraft to refuel in space. This would open up new possibilities for missions to Mars and beyond, as spacecraft could travel farther without being weighed down by fuel from Earth. But the benefits of space mining extend beyond exploration. The rare metals found in asteroids could revolutionize industries back on Earth. Platinum group metals, for instance, are used in everything from electronics to medical devices. By sourcing these materials from space, we could reduce the environmental impact of mining on Earth and meet the growing demand for these critical resources. Of course, space mining isn't without its challenges. The technology required to extract and process materials in space is still in its early stages, and the legal and ethical implications of mining celestial bodies are complex. Who owns the resources in space? How do we ensure that mining operations don't harm the environment or disrupt scientific research? These are questions that will need to be addressed as the field evolves. Despite these challenges, the potential of space mining robots is undeniable. They represent a bold step toward a future where humanity is no longer confined to Earth, but instead thrives as a spacefaring civilization. By turning asteroids and moons into resource hubs, these robots could transform the way we explore and inhabit the cosmos, making the stars a little closer than ever before. Now, let's turn our attention to a development that could redefine the reliability of space missions: self-repairing robots. Picture this: a robot millions of miles from Earth facing a critical malfunction. Instead of waiting for human intervention, it diagnoses the issue, locates the problem, and fixes itself. This isn't just a futuristic dream. It's a reality being actively developed to ensure the success of long-term space exploration. Self-repairing robots are designed to tackle one of the biggest challenges in space maintenance. In the harsh environment of space, where radiation, extreme temperatures, and micrometeoroids pose constant threats, equipment failure is a real risk. Traditional robots, once damaged, often require human assistance or become entirely non-functional. But self-repairing robots change the game. Equipped with advanced sensors, artificial intelligence, and modular components, these machines can detect damage, assess its severity, and perform repairs autonomously. One of the key technologies enabling this capability is modular robotics. These robots are built with interchangeable parts that can be replaced or reconfigured on the fly. For example, if a robotic arm is damaged, the robot can detach the faulty module and replace it with a spare one stored onboard. Some designs even allow robots to cannibalize non-essential components to repair critical systems, ensuring mission continuity even in dire situations. Artificial intelligence plays a crucial role here, enabling robots to make real-time decisions about repairs. Using machine learning algorithms, these robots can analyze data from their sensors to identify the root cause of a problem and determine the most effective repair strategy. This level of autonomy is essential for missions to distant planets or asteroids, where communication delays make real-time human guidance impossible. The benefits of self-repairing robots are immense. For one, they significantly reduce the need for risky and expensive human spacewalks to fix equipment. They also extend the lifespan of missions, allowing robots to operate for years or even decades without requiring maintenance. This is particularly important for deep space missions, where sending replacement parts or repair crews isn't feasible. But the implications go beyond practicality. Self-repairing robots could pave the way for entirely new types of missions. Imagine a fleet of robots exploring the icy moons of Jupiter or Saturn, repairing themselves as they go and continuing their work without interruption. These robots could also support human colonies on the Moon or Mars, maintaining infrastructure and ensuring the safety of astronauts. Of course, developing self-repairing robots isn't without challenges. Creating durable, adaptable components that can withstand the rigors of space is no small feat. Additionally, ensuring that these robots can handle complex repairs without human oversight requires significant advancements in artificial intelligence and robotics. But as technology continues to evolve, the potential for self-repairing robots to revolutionize space exploration grows ever clearer. By enabling robots to fix themselves, we're not just solving a technical problem, we're unlocking new possibilities for exploration and discovery. These resilient machines could become the backbone of humanity's journey into the cosmos, ensuring that no matter how far we go, our robotic companions are ready to adapt, repair, and continue the mission. And with that, let's move on to another fascinating development that's shaping the future of space exploration. Now, let's shift our gaze to the stars and explore how robotic telescopes are transforming our understanding of the cosmos. Imagine a telescope orbiting Earth, silently capturing breathtaking images of distant galaxies, nebulae, and exoplanets, all without human intervention. This is the reality of robotic telescopes like the Hubble Space Telescope and the James Webb Space Telescope, which are autonomously revolutionizing astronomy and space science. Robotic telescopes are designed to operate with minimal human input, using advanced systems to point, focus, and capture images of the universe. These telescopes are equipped with sophisticated sensors and artificial intelligence that allow them to adjust their positioning, calibrate their instruments, and even prioritize targets based on scientific importance. This level of autonomy is crucial for maximizing observation time and ensuring that every moment in orbit is used efficiently. Take the Hubble Space Telescope, for example. Since its launch in 1990, Hubble has provided humanity with some of the most iconic images of space, from the pillars of creation in the Eagle Nebula to the deep field images revealing thousands of galaxies in a single frame. While Hubble isn't fully autonomous, its robotic systems have allowed it to operate for over 3 decades, with periodic upgrades and repairs conducted by astronauts. Its longevity and precision have made it one of the most important tools in modern astronomy. Then there's the James Webb Space Telescope, launched in 2021. This next-generation observatory takes autonomy to a whole new level. Positioned nearly 1 million miles from Earth, Webb is too far for human repair missions, so its robotic systems are designed to handle everything from instrument calibration to thermal management. Its ability to autonomously adjust its massive sun shield and align its 18 hexagonal mirror segments with nanometer precision is nothing short of extraordinary. Already, Webb has delivered stunning images of the early universe, revealing details about the formation of galaxies, stars, and even the atmospheres of distant exoplanets. What makes robotic telescopes so groundbreaking is their ability to capture data that would be impossible to obtain from Earth. Free from the distortions of Earth's atmosphere, these telescopes can observe the universe in unprecedented clarity across a wide range of wavelengths, from visible light to infrared. This has led to discoveries like the accelerating expansion of the universe, the detection of water vapor on exoplanets, and the detailed mapping of dark matter. But the impact of robotic telescopes goes beyond scientific discovery. They've also democratized access to space exploration. Many robotic telescopes, like those in ground-based observatories, are accessible to researchers and even amateur astronomers worldwide. This collaborative approach has accelerated the pace of discovery, allowing scientists to share data and insights in real time. Of course, building and maintaining these marvels of engineering is no small feat. Robotic telescopes require cutting-edge technology, from ultra-sensitive detectors to advanced cooling systems that keep instruments at cryogenic temperatures. They also face challenges like cosmic radiation and micrometeoroid impacts, which can degrade their performance over time. Yet, despite these hurdles, robotic telescopes continue to push the boundaries of what we know about the universe. By autonomously capturing the wonders of space, robotic telescopes are not just expanding our knowledge, they're inspiring humanity to dream bigger. Every image they send back is a reminder of how vast and mysterious the cosmos truly is. And as we continue to develop even more advanced telescopes, the possibilities for discovery are truly limitless. With that, let's turn our attention to another innovation that's shaping the future of space exploration. Now, let's venture into the realm of robotic space stations, where the concept of fully autonomous habitats in orbit is no longer science fiction but a tangible possibility. Imagine a space station orbiting Earth, bustling with activity, conducting experiments, maintaining systems, and even repairing itself, all without a single human on board. This is the vision of robotic space stations, a revolutionary development that could redefine how we explore and utilize space. Robotic space stations are designed to operate independently, leveraging advanced robotics and artificial intelligence to perform tasks traditionally handled by human crews. These stations will be equipped with robotic arms, autonomous systems, and self-repairing technologies, allowing them to conduct scientific research, manage life support systems, and even assemble or upgrade their own components. The idea is to create a self-sustaining environment that can function indefinitely, reducing the need for costly and risky human missions. One of the key advantages of robotic space stations is their ability to operate in environments that are too hazardous or impractical for humans. For instance, they could be positioned in high radiation zones or deep space, where long-term human presence is currently impossible. By removing the need for life support systems tailored to humans, these stations could focus entirely on scientific objectives, such as studying the effects of microgravity on materials, conducting astronomical observations, or testing technologies for future deep space missions. Another exciting possibility is the use of robotic space stations as staging points for interplanetary exploration. These stations could serve as hubs for assembling spacecraft, refueling missions, or even manufacturing tools and components using resources harvested from asteroids or the Moon. By automating these processes, we could significantly reduce the cost and complexity of launching missions from Earth. paving the way for more ambitious endeavors like crewed missions to Mars or beyond. The concept of robotic space stations also opens up new opportunities for international collaboration. Without the logistical challenges of supporting human crews, these stations could be more easily shared among nations, fostering a spirit of cooperation in space exploration. Researchers from around the world could remotely access the station's facilities, conducting experiments and sharing data in real time. This collaborative approach could accelerate scientific discovery and make space exploration more inclusive. Of course, building a fully robotic space station comes with its own set of challenges. Ensuring the reliability of autonomous systems, developing advanced self-repair mechanisms, and creating robust communication networks are just a few of the hurdles that need to be overcome. However, advancements in robotics, artificial intelligence, and materials science are bringing us closer to making this vision a reality. As we look to the future, robotic space stations could play a pivotal role in humanity's journey into the cosmos. They represent a bold step toward a new era of space exploration, where machines and humans work together to unlock the mysteries of the universe. With that, let's turn our attention to another groundbreaking innovation that's shaping the future of space robotics. Now, shifting our focus to the fascinating world of humanoid robots in space, we encounter a development that feels like it's straight out of a sci-fi movie. Picture a robot that looks and moves like a human, capable of performing complex tasks in environments where humans simply cannot go. This is the reality of humanoid robots like NASA Valkyrie, a cutting-edge creation designed to assist astronauts and tackle challenges in the harshest corners of space. Humanoid robots are engineered to mimic human form and function, allowing them to navigate environments built for people. Valkyrie, for example, stands at 6 feet tall and weighs around 300 pounds, equipped with advanced sensors, cameras, and dexterous hands that can manipulate tools and objects with precision. These robots are designed to work alongside astronauts, handling dangerous or repetitive tasks like repairing equipment, conducting maintenance, or even setting up habitats on other planets. By taking on these responsibilities, they free up human crews to focus on more complex and creative aspects of space exploration. One of the most compelling advantages of humanoid robots is their ability to operate in environments that are too hazardous for humans. For instance, they could venture into areas with extreme radiation levels, such as the surface of Europa or the interior of a damaged spacecraft, without risking human lives. Their human-like design also means they can use tools and equipment originally designed for astronauts, making them highly versatile in space missions. Imagine a robot like Valkyrie performing emergency repairs on a space station or assembling structures on the moon, tasks that would otherwise require risky spacewalks. But the potential of humanoid robots goes beyond just assisting astronauts. They could also play a critical role in preparing for human missions to new destinations. By sending these robots ahead of human crews, we can gather valuable data, test equipment, and even build infrastructure, ensuring that when humans arrive, they're stepping into a safer and more prepared environment. This approach could be particularly useful for missions to Mars, where the harsh conditions and long distances make every decision critical. Of course, developing humanoid robots for space comes with its own set of challenges. Creating machines that can move with the agility and precision of humans, while also being robust enough to withstand the rigors of space, is no small feat. Advances in artificial intelligence, materials science, and robotics are pushing the boundaries of what's possible, but there's still much work to be done. For example, improving battery life, enhancing autonomy, and ensuring these robots can operate seamlessly in microgravity are key areas of focus. As we look to the future, humanoid robots like Valkyrie represent a powerful tool in our quest to explore and inhabit space. They embody the idea of humans and machines working together, each complementing the other's strengths. With their ability to perform tasks too dangerous or tedious for humans, these robots could become indispensable partners in our journey to the stars. And speaking of partnerships, let's now explore how robots are teaming up to tackle another critical challenge in space exploration. Now, let's turn our attention to a pressing issue that's been quietly growing above our heads: space debris. As we venture further into the cosmos, the clutter of defunct satellites, spent rocket stages, and other fragments orbiting Earth has become a significant hazard. Enter robotic satellites, the unsung heroes tasked with cleaning up this cosmic mess and ensuring safer orbits for future missions. Space debris, often referred to as space junk, poses a serious threat to both active satellites and spacecraft. With thousands of pieces of debris hurtling through orbit at speeds of up to 17,500 miles per hour, even a tiny fragment can cause catastrophic damage. This is where robotic satellites come into play. These specialized machines are designed to track, capture, and remove debris, helping to clear the way for safer space travel and more reliable satellite operations. One of the most promising approaches involves robotic satellites equipped with advanced sensors and robotic arms. These machines can identify and approach debris using nets, harpoons, or even robotic grippers to capture and secure it. Once captured, the debris is either deorbited to burn up in Earth's atmosphere or moved to a designated graveyard orbit, where it poses no threat to active missions. This process not only reduces the risk of collisions, but also helps prevent the cascading effect known as the Kessler syndrome, where one collision creates more debris, leading to even more collisions. Another innovative solution is the use of robotic satellites with laser technology. These satellites can target smaller pieces of debris using focused beams of light to nudge them out of orbit. While still in the experimental phase, this method shows great potential for handling the vast number of tiny fragments that are difficult to capture with traditional methods. By combining these technologies, robotic satellites are paving the way for a cleaner and more sustainable space environment. The importance of space debris cleanup cannot be overstated. With an increasing number of satellites being launched for communication, navigation, and scientific research, the risk of collisions is higher than ever. Robotic satellites not only protect these valuable assets but also ensure that future missions, whether to the Moon, Mars, or beyond, can proceed without unnecessary risks. They represent a critical step in preserving the long-term viability of space exploration. As we look ahead, the role of robotic satellites in space debris cleanup will only grow more vital. They embody the idea of using technology to solve problems created by technology, turning a potential crisis into an opportunity for innovation. And speaking of innovation, let's now explore how robots are revolutionizing another frontier, building and maintaining habitats on other planets. Now, let's shift our gaze to a future where robots aren't just cleaning up space, they're building it. Imagine a world where robots are the architects and caretakers of habitats on distant planets, creating the foundations for human colonization. This is the exciting promise of robotic space habitats, a concept that could redefine how we live and work beyond Earth. The idea of robotic space habitats revolves around using advanced machines to construct and maintain living spaces on other planets, such as Mars or the Moon. These robots would handle everything from assembling structures to ensuring life support systems are functioning properly, all while operating in environments too harsh or dangerous for humans. Think of them as the ultimate construction workers, equipped with cutting-edge technology to tackle the challenges of extraterrestrial building. One of the key technologies driving this concept is 3D printing. Robots equipped with 3D printing capabilities can use local materials like lunar regolith or Martian soil to create durable structures layer by layer. This approach not only reduces the need to transport heavy building materials from Earth, but also allows for rapid construction in remote locations. For example, NASA Artemis program is already exploring how 3D printed habitats could support long-term lunar missions, paving the way for future human settlements. But building habitats is just the beginning. Robots would also play a crucial role in maintaining these structures over time. From repairing damaged walls to monitoring air quality and temperature, robotic systems would ensure that habitats remain safe and habitable for astronauts. Some designs even include robots that can grow food using hydroponics or aeroponics, creating self-sustaining ecosystems that reduce reliance on Earth for supplies. The benefits of robotic space habitats extend far beyond practicality. By taking on the heavy lifting of construction and maintenance, these robots allow humans to focus on exploration, research, and the broader goals of colonization. They also minimize the risks associated with sending humans into uncharted territories, as robots can test and prepare environments before humans ever set foot on them. As we look to the stars, robotic space habitats represent a critical step in making human colonization of other planets a reality. They embody the spirit of innovation and collaboration, combining human ingenuity with robotic precision to overcome the challenges of living in space. And as we continue to push the boundaries of what's possible, these robotic pioneers will be at the forefront, building the homes of tomorrow on worlds we've only begun to explore. Next, let's dive into how robots could revolutionize another essential aspect of space exploration: growing food in the cosmos. Now, let's turn our attention to a challenge that's as old as space exploration itself: how to feed astronauts on long-term missions. Imagine a future where robots are not just building habitats, but also cultivating fresh, nutritious food in the harsh environment of space. This is the fascinating world of robotic space farms, where advanced hydroponics and artificial intelligence come together to sustain life far from Earth. Robotic space farms are designed to tackle one of the most critical needs for long-term missions: a reliable food supply. Transporting food from Earth is costly, inefficient, and impractical for extended missions to places like Mars or beyond. Instead, robots equipped with hydroponic systems can grow crops in controlled environments, using minimal water and no soil. These systems rely on nutrient-rich water solutions to nourish plants, making them ideal for space where resources are limited. Artificial intelligence plays a pivotal role in these farms. Robots equipped with AI can monitor plant health, adjust lighting, and regulate water and nutrient levels in real time. They can detect issues like nutrient deficiencies or pests before they become problems, ensuring that crops grow efficiently and sustainably. For example, AI-powered robots could analyze data from sensors to optimize growing conditions, tailoring the environment to each plant's specific needs. This level of precision is crucial in space, where every resource must be used wisely. One of the most exciting aspects of robotic space farms is their potential to create self-sustaining ecosystems. Robots could recycle water and nutrients, minimizing waste and maximizing efficiency. Some designs even include closed-loop systems where plants produce oxygen while absorbing carbon dioxide, creating a symbiotic relationship with astronauts. This not only provides fresh food but also contributes to life support systems, making long-term missions more feasible. The benefits of robotic space farms extend beyond practicality. Fresh, homegrown food can have a significant psychological impact on astronauts, boosting morale and providing a sense of normalcy in an otherwise alien environment. Imagine enjoying a salad grown on Mars or a tomato harvested in lunar orbit. These small comforts could make a big difference in the mental well-being of space travelers. As we look to the future, robotic space farms represent a vital step in making long-term space exploration and colonization possible. They combine cutting-edge technology with the timeless need for sustenance, creating a bridge between the challenges of space and the necessities of life. And as these systems continue to evolve, they'll play a key role in ensuring that humanity can thrive beyond Earth, one harvest at a time. Next, let's explore how robots are revolutionizing the way we assemble spacecraft, making space exploration more efficient and cost-effective than ever before. Now, let's shift our focus to a groundbreaking development that's reshaping how we build the tools of space exploration: robotic spacecraft assembly. Picture this: instead of launching massive, fully constructed spacecraft from Earth, robots in orbit could piece together these structures like cosmic engineers working in the vastness of space. This innovative approach not only reduces costs but also opens up new possibilities for designing and deploying spacecraft that were once thought impossible. One of the biggest challenges in space exploration has always been the sheer size and weight of spacecraft. Launching large structures from Earth requires enormous rockets and fuel, making the process incredibly expensive and technically demanding. But what if we could send smaller, modular components into orbit and have robots assemble them there? This is where robotic spacecraft assembly comes into play. By constructing spacecraft in space, we can bypass the limitations imposed by Earth's gravity and atmosphere, allowing for more ambitious designs and missions. Robots designed for this task are equipped with advanced precision tools and artificial intelligence, enabling them to handle delicate assembly work with incredible accuracy. For example, robotic arms could connect solar panels, attach propulsion systems, or even build entire space stations piece by piece. These robots can operate in the harsh conditions of space, performing tasks that would be too risky or time-consuming for human astronauts. And because they can work around the clock without fatigue, they significantly speed up the assembly process. One of the most exciting applications of robotic spacecraft assembly is the potential to create larger, more complex structures than ever before. Imagine telescopes with mirrors the size of football fields or space habitats that dwarf the International Space Station. These structures could be built in orbit, where size and weight constraints are far less restrictive than on Earth. This capability could revolutionize our ability to explore the universe, providing us with tools and infrastructure that were previously unimaginable. Another major advantage of this technology is its cost-effectiveness. Launching smaller, modular components is far cheaper than sending up fully assembled spacecraft. Additionally, robots can reuse materials from defunct satellites or other space debris, further reducing costs and minimizing waste. This approach aligns with the growing emphasis on sustainability in space exploration, ensuring that we make the most of the resources we have. As we look to the future, robotic spacecraft assembly represents a game-changing advancement in space exploration. It not only makes missions more affordable and efficient, but also expands the scope of what we can achieve. By leveraging the power of robotics, we're paving the way for a new era of innovation, where the boundaries of space exploration are limited only by our imagination. Next, we'll dive into how robots are helping us monitor space weather, protecting astronauts and satellites from the unpredictable forces of the cosmos. Now, let's turn our attention to a critical yet often overlooked aspect of space exploration: robotic space weather monitoring. Space weather, which includes phenomena like solar flares and geomagnetic storms, can have a profound impact on both human missions and satellite operations. Without proper monitoring, these unpredictable cosmic events could disrupt communication systems, damage sensitive equipment, and even pose serious risks to astronauts. This is where robots step in, acting as our cosmic sentinels, keeping a watchful eye on the ever-changing conditions in space. Robots designed for space weather monitoring are equipped with specialized sensors and instruments capable of detecting and analyzing solar activity. For instance, they can measure the intensity of solar radiation, track the movement of charged particles, and predict the likelihood of geomagnetic storms. These robots operate autonomously, continuously gathering data and transmitting it back to Earth in real time. This allows scientists and mission controllers to make informed decisions, whether it's adjusting satellite orbits, delaying spacewalks, or shielding sensitive equipment from harmful radiation. One of the key advantages of using robots for this task is their ability to operate in environments that are too hazardous for humans. Solar flares, for example, release bursts of energy that can be dangerous to astronauts, especially during extravehicular activities or long-duration missions. By deploying robots to monitor these events, we can ensure the safety of human crews while still collecting the data needed to understand and predict space weather patterns. Another important application of robotic space weather monitoring is the protection of satellites. Satellites are essential for everything from global communication to weather forecasting, but they are highly vulnerable to the effects of space weather. A single solar flare can disrupt satellite operations, causing communication blackouts or even permanent damage. Robots equipped with advanced monitoring systems can provide early warnings, allowing operators to take preventive measures such as temporarily shutting down non-essential systems or reorienting satellites to minimize exposure. Looking ahead, the role of robots in space weather monitoring is only set to grow. As we venture further into the solar system, understanding and mitigating the effects of space weather will become even more critical. Robots could be deployed to monitor conditions on the Moon, Mars, or even beyond, providing valuable data to support future missions. By leveraging the capabilities of these robotic guardians, we can ensure the safety and success of our endeavors in the cosmos. Next, we'll explore how robots are revolutionizing space communication networks, enabling faster and more reliable data transmission across vast distances. Now, shifting our focus to the backbone of space exploration communication, we dive into the fascinating world of robotic space communication networks. In the vast expanse of space, staying connected is not just a convenience, it's a necessity. Whether it's transmitting data from distant planets or coordinating missions across millions of miles, reliable communication is the lifeline of space exploration. And robots are playing a pivotal role in building and maintaining these networks, ensuring that information flows seamlessly across the cosmos. One of the most significant challenges in space communication is the sheer distance involved. Signals traveling from Mars to Earth, for example, can take anywhere from 4 to 24 minutes depending on the planet's positions. This delay makes real-time communication impossible, which is why robots are stepping in to create more efficient and resilient communication networks. These robotic systems are designed to act as relays, amplifying signals and ensuring that data reaches its destination without degradation. Take, for instance, the concept of robotic relay satellites. These satellites are equipped with advanced communication systems that can receive, process, and retransmit data across vast distances. By positioning these robotic relays at strategic points in space, we can create a network that bridges the gap between Earth and distant spacecraft or planetary rovers. This not only speeds up data transmission but also ensures that critical information, such as scientific findings or mission updates, is delivered accurately and on time. Another groundbreaking application is the use of robots to repair and maintain existing communication infrastructure. Satellites and deep space probes are often exposed to harsh conditions, from micrometeoroid impacts to extreme radiation. Over time, these factors can degrade their communication systems, leading to data loss or delays. Robots equipped with repair tools and AI-driven diagnostics can autonomously identify and fix these issues, extending the lifespan of communication assets and reducing the need for costly human intervention. But the innovation doesn't stop there. Robots are also being developed to create entirely new communication networks in space. Imagine a swarm of small, interconnected robots working together to form a mesh network around a planet or moon. Each robot acts as a node, transmitting data to its neighbors, creating a web of connectivity that can cover vast areas. This approach is particularly useful for missions to remote or rugged terrains, where traditional communication methods might struggle to provide consistent coverage. Looking to the future, robotic space communication networks could revolutionize how we explore the solar system and beyond. By enabling faster, more reliable data transmission, these networks will support everything from real-time control of rovers to the streaming of high-definition images from distant worlds. They'll also play a crucial role in supporting human missions, ensuring that astronauts can stay connected with mission control and access the information they need to succeed. As we continue to push the boundaries of space exploration, the importance of robust communication networks cannot be overstated. And with robots leading the charge, we're not just staying connected, we're building the infrastructure for humanity's next giant leap into the cosmos. Next, we'll explore how robots are stepping into the realm of space tourism, offering assistance and enhancing the experience for future space travelers. Now, let's turn our attention to an exciting frontier where space exploration meets leisure robotic space tourism assistance. As humanity inches closer to making space travel accessible to the public, robots are poised to play a vital role in ensuring that tourists have a safe, enjoyable, and unforgettable experience beyond Earth's atmosphere. Imagine stepping onto a spacecraft not as an astronaut, but as a curious traveler eager to witness the wonders of space. Here, robotic assistants could be your companions, guiding you through every step of the journey. These robots would be equipped with advanced sensors and artificial intelligence to monitor your health, ensuring you're comfortable and safe in the unique environment of microgravity. From helping you adjust to weightlessness to providing real-time updates on your vitals, these robotic assistants would act as your personal guardians in the cosmos. But their role goes beyond safety. Space tourism is all about creating memorable experiences, and robots could enhance this by serving as knowledgeable guides. Picture a robot narrating the history of the International Space Station as you float through its modules or pointing out constellations through a spacecraft window. With access to vast databases, these robots could answer questions, share fascinating facts, and even tailor their interactions to match your interests, making your journey both educational and entertaining. Entertainment is another area where robotic assistants could shine. Long-duration spaceflights, especially those aimed at destinations like the Moon or Mars, could benefit from robots designed to keep passengers engaged. Whether it's leading interactive games, projecting immersive virtual reality experiences, or even performing light-hearted routines to lift spirits, these robots could help combat the isolation and monotony that can come with space travel. Moreover, robots could assist in the logistical aspects of space tourism, from managing luggage and supplies to preparing meals in zero-gravity kitchens. They could handle the behind-the-scenes tasks that ensure a smooth and stress-free experience for travelers. This would allow human crew members to focus on more complex responsibilities, while robots take care of the day-to-day operations. Looking ahead, the integration of robots into space tourism could redefine how we think about leisure beyond Earth. As private companies and space agencies work toward making space travel more accessible, robotic assistants will likely become an indispensable part of the experience. They won't just be tools, they'll be companions, educators, and entertainers, helping to make the dream of space tourism a reality for people around the world. With robots paving the way for safer, more engaging, and more enjoyable space travel, the future of tourism is truly out of this world. Next, we'll venture into the realm of robotic space archaeology, where robots could uncover the secrets of ancient sites on other planets and moons, offering us a glimpse into the history of our solar system. Now, let's shift our gaze to a fascinating intersection of robotics and history: robotic space archaeology. Imagine robots as cosmic detectives, venturing to distant worlds to uncover the secrets of ancient sites that could rewrite our understanding of the solar system's past. These robotic explorers would be equipped with cutting-edge tools to analyze and preserve extraterrestrial artifacts, offering us a window into events that shaped planets and moons billions of years ago. Picture a robot carefully navigating the rugged terrain of Mars, scanning the surface for signs of ancient riverbeds or volcanic activity. With advanced imaging technology and precision instruments, it could uncover geological formations that tell the story of a time when water flowed freely on the red planet. These discoveries wouldn't just satisfy our curiosity, they could provide critical insights into whether life ever existed beyond Earth. But the potential of robotic space archaeology extends far beyond Mars. Consider the Moon, where robots could explore long-buried craters or analyze lunar rocks to piece together the history of our closest celestial neighbor. By studying these ancient materials, robots could reveal clues about the Moon's formation and its role in shaping Earth's early environment. This knowledge could deepen our understanding of how our own planet evolved over billions of years. One of the most exciting possibilities lies in exploring icy moons like Europa or Enceladus, where robots could investigate subsurface oceans for signs of ancient microbial life. By drilling through thick layers of ice and analyzing samples, these robotic archaeologists could uncover evidence of past biological activity, offering tantalizing hints about the potential for life elsewhere in the solar system. Such discoveries would not only expand our scientific knowledge, but also spark profound questions about our place in the universe. Robotic space archaeology also raises intriguing questions about the preservation of extraterrestrial heritage. As robots uncover ancient sites, they would need to balance exploration with conservation, ensuring that these priceless artifacts remain intact for future generations to study. This delicate work would require robots to be both precise and adaptable, capable of making decisions in real time to protect the integrity of their discoveries. As we look to the future, robotic space archaeology promises to transform our understanding of the solar system's history. These robotic explorers could reveal stories written in stone, ice, and dust, offering us a glimpse into the distant past and inspiring new questions about the origins of life and the forces that shaped our cosmic neighborhood. Next, we'll dive into the world of robotic space medicine, where robots are being developed to provide critical healthcare support for astronauts on long-duration missions. Now, let's turn our attention to a critical frontier in space exploration: robotic space medicine. As humanity sets its sights on longer missions to the Moon, Mars, and beyond, the need for advanced medical care in space becomes more urgent than ever. Robots are stepping up to fill this vital role, offering everything from diagnostics to surgical procedures, ensuring astronauts stay healthy even millions of miles from Earth. Imagine a scenario where an astronaut experiences a medical emergency during a mission. With no hospitals or doctors nearby, the crew would rely on robotic systems equipped with artificial intelligence to assess the situation. These robots could perform detailed scans, analyze symptoms, and even suggest treatment plans, all while communicating with medical experts back on Earth. This real-time collaboration could mean the difference between life and death in the harsh environment of space. One of the most groundbreaking applications of robotic space medicine is in the field of surgery. Robots designed for space are being developed to perform delicate procedures with precision, even in microgravity. Picture a robotic arm equipped with tiny surgical tools, guided by artificial intelligence and remote human operators. It could stitch wounds, remove foreign objects, or even assist in more complex surgeries, all while minimizing the risk of human error. These robotic surgeons would be compact, adaptable, and capable of functioning in the confined spaces of a spacecraft or habitat. But robotic space medicine isn't just about emergencies. Robots could also play a key role in preventive care, monitoring astronauts' health throughout their missions. Wearable devices and robotic systems could track vital signs, detect early signs of illness, and recommend lifestyle adjustments to keep the crew in peak condition. This continuous health monitoring would be especially crucial on long-duration missions, where even minor health issues could escalate without timely intervention. Another exciting possibility is the use of robots to manufacture medical supplies in space. Imagine a 3D printing robot that can produce custom bandages, splints, or even medications on demand. This capability would reduce the need to carry large medical inventories, freeing up valuable space and resources for other mission-critical equipment. It's a perfect example of how robotics can solve practical challenges while enhancing the safety and efficiency of space exploration. As we look to the future, robotic space medicine promises to revolutionize how we care for astronauts on their journeys through the cosmos. These robotic systems will not only address immediate medical needs, but also pave the way for longer, safer, and more ambitious missions. Next, we'll explore how robots are being designed to harvest energy in space, powering the next generation of exploration and habitation. Now, let's shift our focus to another game-changing development in space exploration robotics: robotic space energy harvesting. As missions venture farther into the cosmos, the need for reliable and sustainable energy sources becomes increasingly critical. Robots are stepping up to the challenge, harnessing the power of the sun and even nuclear energy to fuel the next generation of space exploration. Picture this: a fleet of robotic systems deployed on the Moon or Mars, equipped with advanced solar panels designed to capture and store energy from the sun. These robots could autonomously position themselves to maximize sunlight exposure, even in challenging environments like the Moon's polar regions where sunlight is scarce. By efficiently collecting and storing solar energy, these robotic systems could provide a steady power supply for habitats, rovers, and scientific instruments, ensuring that missions can continue uninterrupted. But solar energy isn't the only option. Robots are also being developed to harness nuclear energy in space. Imagine a robotic system capable of safely extracting and processing radioactive materials from asteroids or moons. These materials could then be used to power compact nuclear reactors, providing a reliable energy source for long-duration missions or even permanent settlements. This approach would be particularly valuable in deep space, where sunlight is too weak to generate sufficient power. One of the most exciting aspects of robotic space energy harvesting is its potential to enable self-sustaining missions. Robots could not only collect energy but also distribute it across a network of habitats, rovers, and other equipment. For example, a robotic rover could act as a mobile charging station, delivering power to remote outposts or stranded vehicles. This kind of flexibility would be a game-changer, reducing the need for constant resupply missions from Earth and making long-term exploration more feasible. Another innovative application is the use of robots to construct and maintain large-scale energy infrastructure in space. Imagine a team of robots working together to assemble massive solar arrays or nuclear power plants in orbit or on the surface of another planet. These systems could provide energy for entire colonies, supporting everything from life support systems to advanced research facilities. By automating these tasks, robots would not only save time and resources but also reduce the risks to human crews. As we look to the future, robotic space energy harvesting holds the key to unlocking the full potential of space exploration. By providing reliable, sustainable energy sources, these robotic systems will enable longer, more ambitious missions and pave the way for humanity's expansion into the cosmos. Next, we'll dive into how robots are working together in teams to explore distant planets, sharing data and adapting to challenges collectively. Now, let's turn our attention to an exciting frontier in space exploration: robotic teams working together to explore distant planets. Imagine a group of robots, each with specialized skills, collaborating seamlessly to tackle the challenges of alien environments. This concept of robotic space exploration teams is revolutionizing how we approach missions, making them more efficient, adaptable, and capable of handling the unpredictable nature of space. Picture a team of robots landing on a distant planet like Mars or Europa. One robot might be equipped with advanced sensors to map the terrain, while another carries tools to collect and analyze soil samples. A third robot could act as a communication hub, relaying data back to Earth or to a nearby spacecraft. By working together, these robots can cover more ground, gather diverse data, and solve problems collectively. For example, if one robot encounters a steep cliff or a deep crater, another robot with climbing capabilities or a different set of tools can step in to assist. This teamwork ensures that no obstacle is too great and no opportunity for discovery is missed. One of the most remarkable aspects of robotic teams is their ability to share information in real time. Using advanced communication systems, these robots can exchange data, update each other on their findings, and adjust their strategies on the fly. If one robot detects signs of water or unusual geological formations, it can immediately alert the rest of the team, allowing them to focus their efforts on the most promising areas. This level of coordination not only speeds up exploration, but also increases the chances of making groundbreaking discoveries. Another advantage of robotic teams is their adaptability. Space is full of surprises, and missions often encounter unexpected challenges. A single robot might struggle to adapt to sudden changes, but a team of robots can pool their resources and expertise to overcome obstacles. For instance, if a robot's sensors malfunction, another robot can step in to provide the necessary data. If a mission requires a new type of analysis, the team can redistribute tasks to ensure that all objectives are met. This flexibility makes robotic teams ideal for long-duration missions where conditions can change rapidly. The potential applications of robotic space exploration teams are vast. They could be used to explore the icy moons of Jupiter and Saturn, search for signs of life on distant exoplanets, or even prepare the way for human missions by building infrastructure and conducting preliminary surveys. By working together, these robots can achieve far more than any single machine could on its own, paving the way for a new era of discovery and exploration. As we look ahead, the concept of robotic teams opens up incredible possibilities for space exploration. By combining the strengths of multiple robots, we can tackle the most challenging environments in the cosmos and uncover secrets that have remained hidden for billions of years. Next, we'll explore how robots are not just tools for exploration, but also creators of art and culture in space, enriching the lives of astronauts and future space settlers. Now, let's shift our focus to a fascinating and often overlooked aspect of space exploration: the role of robots in creating art and culture beyond Earth. While we often think of robots as tools for science and engineering, their potential to contribute to the cultural and emotional well-being of astronauts and future space settlers is equally groundbreaking. Imagine a robot painting a mural on the walls of a lunar habitat or composing music inspired by the sounds of distant planets. These creative endeavors could bring a sense of beauty, inspiration, and humanity to the stark and isolating environment of space. One of the most exciting possibilities is the use of robots to create art that reflects the unique experiences of living in space. For instance, a robot equipped with cameras and sensors could capture the breathtaking views of Earth from orbit or the surreal landscapes of Mars, transforming these images into paintings or digital art. Another robot might use materials found on the Moon or asteroids to sculpt intricate designs, blending science and creativity in ways that celebrate the wonders of the cosmos. These artistic creations could serve as a reminder of the beauty and mystery of the universe, fostering a deeper connection between space explorers and their surroundings. Beyond visual art, robots could also play a role in creating cultural experiences that enrich the lives of astronauts. Imagine a robot programmed to perform music or dance, offering entertainment and relaxation during long missions. These performances could be tailored to the preferences of the crew, providing a sense of familiarity and comfort in an otherwise alien environment. Additionally, robots could help preserve and share cultural traditions from Earth, ensuring that future space settlers maintain a connection to their heritage even as they venture into the unknown. The impact of robotic art and culture extends beyond individual well-being. It could also play a crucial role in building a sense of community among space settlers. Collaborative art projects facilitated by robots could bring people together, encouraging creativity and teamwork. For example, a group of settlers might work with a robot to design and construct a communal space that reflects their shared values and aspirations. These projects could help foster a sense of belonging and purpose, which is essential for the long-term success of human settlements in space. As we look to the future, the integration of art and culture into space exploration through robotics opens up new possibilities for how we experience and understand life beyond Earth. By combining the technical capabilities of robots with the boundless creativity of human imagination, we can create a richer, more meaningful existence in space. Next, we'll explore how robots are stepping into the role of protectors, ensuring the safety and security of space assets in an increasingly complex environment. Now, let's turn our attention to a critical yet often underappreciated aspect of space exploration: robotic space security. As humanity expands its presence beyond Earth, the need to protect our space assets, satellites, space stations, and even future lunar or Martian bases becomes increasingly vital. Robots are stepping into this role, acting as guardians against a range of threats, from cyber attacks to physical sabotage, ensuring the safety and integrity of our extraterrestrial infrastructure. One of the primary challenges in space security is the vast and unpredictable nature of the environment. Space is not only physically hostile, but also a frontier where traditional security measures fall short. This is where robots come in, equipped with advanced sensors, artificial intelligence, and autonomous decision-making capabilities. These robotic guardians can monitor and defend space assets in real time. For example, a robot stationed on a satellite could detect and neutralize an incoming piece of space debris, preventing catastrophic damage. Similarly, robotic systems could patrol the perimeter of a lunar base, identifying and responding to potential intruders or hazards. Cyber attacks pose another significant threat to space operations. As our reliance on digital systems grows, so does the risk of malicious interference. Robots designed for cybersecurity can play a crucial role in safeguarding these systems. Imagine a robot programmed to constantly scan for vulnerabilities in a space station's network, identifying and patching weaknesses before they can be exploited. These robotic defenders could also detect and counteract hacking attempts, ensuring that critical systems remain operational and secure. Physical sabotage is another concern, especially as space becomes more crowded and competitive. Robots can act as sentinels, patrolling key installations and deterring unauthorized access. For instance, a robotic security system could use cameras and motion sensors to monitor activity around a space habitat, alerting human operators to any suspicious behavior. In more advanced scenarios, robots might even be equipped with non-lethal deterrents, such as laser-based systems, to neutralize threats without causing harm to the environment or other assets. The integration of robots into space security also opens up new possibilities for collaboration. Teams of robots could work together to create a layered defense system, with each robot specializing in a specific task. One robot might focus on surveillance, while another handles cyber defense, and yet another is ready to respond to physical threats. This collaborative approach ensures comprehensive protection, addressing multiple risks simultaneously. As we look to the future, the role of robots in space security will only grow more important. With the increasing complexity of space missions and the rising stakes of protecting valuable assets, these robotic guardians will be essential in maintaining the safety and stability of our extraterrestrial endeavors. Next, we'll dive into how robots are revolutionizing education in space, providing astronauts and future settlers with the knowledge and skills they need to thrive in this new frontier. Now, let's shift our focus to an exciting and transformative development in space exploration: robotic space education. As humanity ventures further into the cosmos, the need for continuous learning and skill development becomes paramount. Robots are stepping into the role of educators, providing astronauts and future space settlers with the knowledge and training they need to thrive in the challenging environment of space. Imagine a scenario where a robot acts as a personal tutor for an astronaut, guiding them through complex procedures or troubleshooting equipment malfunctions. These robotic educators could be equipped with vast databases of information, capable of delivering lessons tailored to the individual's needs. For instance, a robot could teach an astronaut how to repair a malfunctioning life support system, using interactive simulations and step-by-step instructions. This not only enhances the astronaut's skills, but also ensures that critical tasks can be performed efficiently, even in the absence of direct communication with Earth. Robots could also play a crucial role in training future space settlers. As we establish colonies on the Moon or Mars, settlers will need to learn a wide range of skills from agriculture to engineering. Robotic educators could provide hands-on training, using virtual reality and augmented reality to create immersive learning experiences. Picture a robot teaching a group of settlers how to grow crops in a hydroponic farm, demonstrating techniques and offering real-time feedback. This kind of interactive education would be invaluable in helping settlers adapt to their new environment and become self-sufficient. Another fascinating aspect of robotic space education is the potential for lifelong learning. In the confined and isolated environment of a space station or colony, continuous education can help combat boredom and maintain mental well-being. Robots could offer a variety of courses, from scientific subjects to creative arts, allowing astronauts and settlers to pursue their interests and expand their knowledge. This not only enriches their lives but also fosters a sense of community and shared purpose. Moreover, robots could serve as mentors for younger generations growing up in space. As space colonization becomes a reality, children born on other planets will need access to quality education. Robotic teachers could provide a consistent and reliable source of instruction, ensuring that these children receive a well-rounded education despite the challenges of their environment. From basic literacy to advanced scientific concepts, robots could cover a wide range of subjects, preparing the next generation for the complexities of life in space. The integration of robots into space education also opens up possibilities for collaborative learning. Robots could facilitate group activities and discussions, encouraging teamwork and problem-solving among astronauts and settlers. For example, a robot could organize a workshop on space habitat design, guiding participants through the process of creating sustainable living spaces. This collaborative approach not only enhances learning outcomes but also strengthens the bonds within the community. As we look to the future, the role of robots in space education will be crucial in ensuring the success and sustainability of our extraterrestrial endeavors. By providing accessible, personalized, and engaging educational resources, these robotic educators will empower astronauts and settlers to overcome challenges and achieve their goals. Next, we'll explore the fascinating concept of robotic space-time capsules, where robots preserve humanity's knowledge and achievements for future civilizations. Now, let's venture into a concept that feels like it's straight out of a science fiction novel: robotic space-time capsules. Imagine a future where robots are tasked with preserving the essence of human civilization, safeguarding our knowledge, culture, and achievements for generations, or even civilizations yet to come. This isn't just about leaving a mark, it's about creating a legacy that transcends time and space. Picture this: robots meticulously gathering and storing data, artifacts, and records of humanity's greatest accomplishments. These robotic archivists could be designed to compile everything from scientific discoveries and historical events to cultural treasures like music, art, and literature. The goal: to create a comprehensive snapshot of who we are as a species, preserved in a durable, space-worthy capsule that could withstand the test of time, literally. These capsules could be placed on the Moon, Mars, or even sent into deep space, waiting to be discovered by future explorers or extraterrestrial beings. One of the most fascinating aspects of this idea is the technology behind it. Robots would need to be equipped with advanced data storage systems capable of preserving information for thousands or even millions of years. Think about materials that resist radiation, extreme temperatures, and the vacuum of space. The robots themselves would need to be highly autonomous, able to select, organize, and encode data in ways that future civilizations could decode, even if they have no knowledge of our languages or technologies. But it's not just about the hardware. The content of these time capsules would need to be carefully curated. Robots could use artificial intelligence to determine what information is most representative of humanity's progress and diversity. For example, they might include breakthroughs in medicine, engineering, and space exploration, alongside cultural milestones like the first moon landing or the invention of the internet. They could also store personal stories, photographs, and messages from people around the world, creating a mosaic of human experience. The placement of these time capsules is another intriguing consideration. Robots could deploy them in locations that are likely to remain undisturbed for millennia, such as the far side of the Moon or beneath the surface of Mars. Alternatively, they could launch capsules into interstellar space, where they might one day be intercepted by an advanced civilization. Each location would carry its own significance, turning these capsules into cosmic milestones of human achievement. What makes this concept truly revolutionary is its potential to inspire. Knowing that our knowledge and culture are being preserved for the future could motivate us to strive for greater accomplishments. It's a reminder that our actions today have the power to shape the legacy we leave behind. And for future generations or even alien civilizations, these time capsules could serve as a testament to humanity's ingenuity, resilience, and curiosity. As we wrap up this exploration of robotic space-time capsules, it's clear that this idea represents more than just technological innovation. It's a profound statement about our desire to connect with the unknown and leave a lasting impact on the universe. Next, we'll bring our journey to a close by reflecting on the incredible advancements we've covered and what they mean for the future of space exploration. As we bring this journey through the 25 revolutionary developments in space exploration robotics to a close, it's impossible not to feel a sense of awe at how far we've come and how much further we can go. From autonomous rovers navigating alien terrains to robotic arms assembling structures in orbit, each innovation represents a leap forward in our ability to explore and understand the cosmos. These advancements aren't just about technology, they're about expanding the boundaries of what humanity can achieve. They're paving the way for a future where humans and robots work side by side to unlock the mysteries of the universe, mine resources from asteroids, build habitats on distant planets, and even preserve our legacy for civilizations yet to come. What ties all these developments together is their collective potential to transform how we interact with space. They're not isolated breakthroughs but interconnected pieces of a larger vision, one where space exploration becomes more accessible, sustainable, and impactful. Whether it's robotic telescopes revealing the secrets of distant galaxies or humanoid robots assisting astronauts in hazardous environments, each innovation brings us closer to a future where space is no longer a frontier but a home. But this isn't just a story about robots, it's a story about us. These technologies reflect our curiosity, our resilience, and our determination to push beyond the limits of what we know. They remind us that the challenges of space exploration are not insurmountable. They're invitations to innovate, collaborate, and dream bigger. Now it's your turn to join the conversation. Which of these 25 developments excites you the most? Is it the idea of robotic space farms sustaining life on Mars, or perhaps the thought of swarms of robots mapping uncharted worlds? Let us know in the comments below. We'd love to hear your thoughts. And if you're as fascinated by the future of space exploration as we are, don't forget to hit that subscribe button and ring the notification bell. There's so much more to explore, and we can't wait to take you on the next adventure into the incredible world of futuristic technologies. Until then, keep looking up because the future is closer than you think.